Number 6. Square root of 11/12. Again, can I reduce? No. Are there any perfect squares? Yes. There are no perfect squares inside the 11, but there are perfect squares inside the 12. Take those out first. The 12, that's the same thing as 4 times 3. 4 is a perfect square, so I can take that out. The 4 comes out as a 2. The 3 is still inside the radical. And on top I have the square root of 11. Did we follow that again? The 12 can be broken down to 4 times 3. Since 4 is a perfect square, the square root of 4 is 2. That's why it comes outside. The 3 is not a perfect square, therefore it stays inside. And the top remains radical 11. Now, rationalize the denominator. Times radical 3 times radical 3 equals. On the top, I get the square root of 33. On the bottom, radical 3 times radical 3 gives me 3. Multiply it times the 2. So that's 3 times 2, 6. Number 7. Square root of 8 over 32. Again, step 1. Can we reduce? Yes, we can. 8 goes into itself, and 8 goes into 32. So what you're left with is a square root of 1/4. From there, are there any perfect squares? Yes. The denominator is a perfect square. So this will give me the square root of 1 over 2. This is square root of 4, it's 2. Notice, I do not keep a radical over the 2. When you take the square root of a number, you take it out of the radical. The square root of 1, you don't need to keep a square root over 1, all right? Square root of 1 is 1. Therefore, the answer is just 1/2. Number 8. 12 radical 7 over radical 12. Again, step 1. Can I reduce? No. 7 and 12 cannot reduce. And I cannot reduce this with this, because this is the outside, this is the inside. And I cannot reduce the outside with the inside. So I cannot reduce anything. Step 2. Are there any perfect squares? Yes. There is a perfect square inside the 12. I think we just did it on the last problem, so perhaps you remember. This is 4 times 3. There's my perfect square. So this comes outside as a 2, leaving this inside as a 3, and I have 12 radical 7. From there, you could reduce right now the outsides, or you could wait and reduce when you're finished. Same. I'll wait till I'm finished. Multiply by radical 3. I'm going to get 12 radical 21 all over. This gives me 3 times 2, 6. And then I can reduce these, which just gives me 2 times radical 21. Nine. I'm sure you guys are having as much fun as I am. That's your point. Okay. Start off. Can I reduce? No, I cannot. 9 and 20 do not reduce. Perfect squares? Yes. I have perfect squares on the top and perfect squares on the bottom. Do those first. On the top, the square root of 9 is 3. Notice, no radical. The square root of 9 is just 3. On the bottom here, the 20, this is 4 times 5. There's my perfect square. I'm going to take this out of the radical and multiply it times this. So that's the square root of 4 is 2. 2 times 2 gives me 4. So I'll have a 4 with this left over. Again, if you're slightly confused there, the 4 and the 5 give me my 20. So, since the 4 is a perfect square, the square root of 4 is 2. I take that out, and I multiply it times this 2, and that gives me the 4. And the 5 is left over. Now, step 3. Rationalize the denominator. So, multiply times radical 5. And this gives me 3 radical 5 all over. This gives me 5 times 4. Nothing on the outside can be reduced. You're finished. Number 10. Radical 30 over 25. Can I reduce? Yes, so do it. I can reduce by 5. This gives me the square root of 6 all over 5. Are there any perfect squares? No. Rationalize the denominator. This gives me the square root of 30 all over 5. You're finished. Square root of 72 over 80. Okay. Can I reduce? Yes. 8 can go into both of these. 8 goes into this 9 times. 8 goes into this 10 times. Next, are there any perfect squares? Yes. 9 is a perfect square. So this gives me 3 over radical 10. And now, rationalize. Times the square root of 10. Times the square root of 10. This gives me 3 radical 10